I'm all about that bass, no trouble. I'm all about that bass, no trouble.
All about the bass? Well, there's more to the story than just bases. There are acids too. Good evening. My name is Elizabeth and this is Chemistry at 10. We will look at the definition of an acid and a base. We will describe acids as proton donors and bases as proton acceptors. We will hear from a dental expert who explains how toothpaste works. And we will visit a farmer in Somerset to hear about neutralising acid soils to promote crop growth. But first we are going live to the kitchen to find out about acids and bases in the home. Hello, is that Megan? Good evening. This is the pH scale. It is a scale used to describe how acidic or how basic a substance or solution is. As you can see, the scale goes from 0 to 14, and right in the middle is 7. This indicates neutrality. This is where you will find water. It is neither acidic or basic. Hello Megan, before you go any further, could you explain what is meant by acidic and basic? Yes, acidic substances or solutions have hydrogen ions present. The more acidic something is, the higher the concentration of hydrogen ions. Anything with a pH of less than 7 is an acid. The lower the number, the more acidic it is. A base has OH- ions. Again, the higher the concentration of OH- ions, the more alkali or basic the substance is. The pH will be greater than 7. Here is our household pH scale. As you can see, at 0 we have hydrochloric acid. We can move along to pH 3 where we've got lemonade. At pH 4 we have chocolate, cream cheese and vinegar. 5 is distilled water and coffee. We're getting more alkaline now. At 6 we have eggs, cocoa, orange juice and pasta. As we've said, 7 is neutral and is water. We're now alkaline. pH 8 is mushrooms, bananas, tomatoes and red peppers. 9 is sweet potatoes. pH 10 is soaps, spinach, broccoli and household cleaners. Moving along to pH 12 with antacids. 13 is bleach and toilet cleaner, and 14 we have sodium hydroxide. You may notice that most foods are acidic, whereas cleaners and antacids are alkaline. Back to you in the studio. Thank you, Megan. That was interesting, especially the last fact. To explain more, our studio guest this evening is Dr. Litmus Jones. Dr. Jones, can you explain this phenomenon? Yes, I can. You see, acids are proton donors. The stronger the acid, the higher the concentration of hydrogen ions, and they all need to do something. Alkalis are proton acceptors. We refer to protons as a hydrogen ion is basically a proton. Nothing more, nothing less. If the proton reacts with the OH-, which will be present in the alkali substances, the H+ and the OH- will combine to make water. And as we have seen, water is neutral. This type of reaction is called a neutralisation reaction, and it is very useful. Thank you, Dr. Jones. That was a brilliant explanation. Oh, we're just off to an outside broadcast from our dental expert, live from the bathroom. Sounds great. Good evening. I'm brushing my teeth. Now, we all know the benefits of brushing teeth, but do you know what's happening? Let me explain. After a day of eating, your teeth might be covered in a thin film of food. You might even have bits of food stuck between your teeth. Most food is acidic. If you don't brush your teeth, bacteria in your mouth will break down the food and make more acids, which will rot the enamel on your teeth and could lead to tooth decay. Toothpaste is an alkali. Not only are you cleaning away food from the surface of your teeth and in between your teeth, you are also using the alkalinity in the toothpaste to neutralise the acid in your mouth. Once again, H+ ions react with OH ions to produce neutral water molecules, so remember to brush your teeth, especially now you know why. Back to you, Elizabeth. We've covered a lot in this programme already. We found out about the pH scale and how neutralisation can be used to make something neutral when it is alkali or acid. Sorry about that, we've got one more film to show you. Let's go to Farmer Bob to find out how he uses neutralisation in farming.
See, carbon dioxide is being acid soil. They're right, that's what happened. It's neutral soil. So now, as calcium carbonate as well. Clever thing. Carbonate will react, produce carbon dioxide and salt and water. All sounds good to me. I could get a good cabbage crop this summer. I'm Bob. Bye.
Thank you, Bob. Where did he get that accent? This has been Chemistry at 10. I am Elizabeth and we have been talking about acids and bases. Good night.
No, I'm all about that bass, no trouble. I'm all about that bass, no trouble.